Hi everybody and welcome to this lecture. In this lecture I'm going to talk more about Oracle GoldenGate. In this lecture you should be able to understand the advantages of using user exits, understand the requirements to implement user exits, describe the procedure to build up Oracle GoldenGate topologies, use Oracle GoldenGate to implement a standby database, understand in high level how to configure Oracle GoldenGate high availability, and finally understand the areas to cover for further Oracle GoldenGate knowledge. User exits are custom logic written by the Oracle GoldenGate clients in C or C++ languages. They can be invoked from the GoldenGate extract or replicate processes through the C user exit parameter. C language is considered a low-level language which provides a wide range of capabilities that GoldenGate doesn't provide. For this reason, user exits are mainly used to extend the Oracle GoldenGate capabilities. For example, you can use the advanced arithmetic operations in the C language, or use the date conversion functions, or retrieve lookup data from external sources. You can even call external programs, like email client software, to send a notification via the email, or a custom application, or you can call a custom application for integration purposes with other applications. User exits can also be used to implement complex criteria that uses the C language advanced functions. An additional possibility of using the user exit is to save the data in external flat files. The replicate process passes the data to the user exit routine, and the routine saves the data into the flat files. This diagram illustrates the process flow when you use the user exit. A GoldenGate process, which could be either an extract or a replicate, will use the user exit as an interface between the process and the external routine. The GoldenGate process sends the data to the user exit. The user exit passes the data to the routine. The routine processes the data and returns a response to the user exit. The user exit sends back the response to the extract or replicate. When using user exit, not much is required from GoldenGate side. Most of the core processing is done in the routine side. As this requires programming with C or C++, developing such a routine is beyond the scope of this course. In high level, you need to develop a DDL routine in Windows or a shared object in Linux. This routine will process the data that it receives from the GoldenGate process. When you develop the routine, you must include the usr.decs.h file, which is shipped with the Oracle GoldenGate in its root directory. You can find some sample user exit files in the folder User Exit Examples under the Oracle GoldenGate root directory. In the slide, you can see examples on how to call Oracle exits from an Oracle GoldenGate parameter file. You have learned in the course how to set up a unidirectional configuration and a bidirectional configuration. Based on what you have learned so far, you can build up any of the GoldenGate topologies. I will explain in the incoming slides the steps that you should follow to create the GoldenGate topologies that are shown in the slide. Peer-to-peer multi-master configuration is an active-to-active configuration between multiple databases. In other words, it is a bidirectional configuration among a group of databases. This configuration is usually used to eliminate system performance issues in distance-separated applications. It allows the changes in any database in the configuration. The downside of this configuration is that you always have to monitor the system for data conflicts. The procedure you follow to set up this configuration is typically the same as the steps you learned to set up a bidirectional configuration between two databases. In each database, you set up an extract, a data pump, a replicate, and CDR rules. A data distribution configuration is a one-to-many configuration where you have one source database distributing the data to any number of target databases. This is very similar to the unidirectional configuration. In the source database, you would have one extract group and a data pump group for each target database. In the target system, you typically configure one replicate group. A data warehousing configuration is a many-to-one configuration. You would have multiple source databases sending data to one target warehouse database. To set up this topology, you configure an extract and a data pump process group in each source database. In the target system, you configure a replicate group for each source database. Usually in this configuration, each source database contributes different records to the target system. If conflicts could happen in the configuration, you need to set up conflict resolution routines to resolve the conflicts. Oracle GoldenGate supports cascading configuration. In this configuration, data changes are propagated from the source database to a second database, and then on to a third database. This configuration is used when you are sending data to one or more servers that are very far apart from each other. It can also be used in a scenario where one or more of the target systems do not have a direct connection to the source, but the second system can connect in both directions. To set up this configuration, you configure an extract and data pump process group in the source system. In the second database, you configure a replicate, an extract, and a data pump group process. There is something new you must be aware of when you configure the extract in the second database. You should include the parameters ignore applobs and get replicates in the parameter file of the extract group. Those parameters make the extract group to capture the replicate activity and to ignore local business application activity. This is because the target of this database is only to send the data to that third database. In the third database, you configure the replicate to apply the data received from the second database. With Oracle GoldenGate, you can configure a standby database. A standby database is a database that the applications can connect to in case of planned or unplanned outages on the production database. This is typically an active-passive bidirectional configuration where Oracle GoldenGate replicates data from an active primary database to a full replica database on a live standby system. In normal case, the groups that synchronize the data in one direction from the primary database to the standby database will be active. But the GoldenGate process groups, which are responsible for the synchronization on the other direction, will be inactive. Typically, they will be shut down. Those groups remain stopped until just before user applications are switched to the live standby system in a switchover or failover scenarios. When user activities move to the standby database, you start up the extract in the standby system to capture the transactions into a local trail, where the data is stored on disk until the primary database is back up again. When the primary database is up and running again, you start up the data pump in the standby database and the replicate in the primary database to synchronize the primary database. At the appropriate time, users are moved back to the primary system, and Oracle GoldenGate is configured in ready mode again in preparation for future failovers. However, in my personal opinion, if your database is Oracle database, the best solution to implement this functionality is Oracle Data Guard. It is well designed for this solution. For high availability configuration, Oracle GoldenGate can be installed on a cluster of servers. The GoldenGate process will be active only on one node at a time. If that active node fails, another node will take over the processing. This is called active-passive mode. This is different from Oracle RAC, where all the database instances can run at the same time in the cluster nodes. To implement this high availability configuration in Oracle GoldenGate, you can use Oracle Clusterware. You will need to configure a shared storage to save the GoldenGate checkpoint and trail files. Shared storage can be configured using ACFS, OCFS2, or DBFS. ACFS is the recommended option. In high level, the procedure includes installing Oracle Clusterware, configure VIP, setting up the shared storage, installing Oracle GoldenGate, creating the agent script, adding the Oracle GoldenGate as a Clusterware resource, and finally starting the resource. The details of implementing this procedure is described in the document 1527.310.1. You have learned in the course the enough knowledge to establish a production replication configuration between two Oracle databases by using Oracle GoldenGate. However, not everything about the Oracle GoldenGate has been covered in this course. You have worked on Oracle databases, but as you know, Oracle GoldenGate can be configured on many more database vendors. If you visit Oracle Learning Library site, you will see heaps of tutorials that describe how to configure Oracle GoldenGate in nearly all the supported databases. In addition to that, I promise to add in the near future a practice on how to configure Oracle GoldenGate in SQL Server. There is a product called Oracle GoldenGate Management Pack. This product enables you to easily monitor and manage Oracle GoldenGate configurations. It is shipped with a Monitor Agent plugin which enables you to monitor an Oracle GoldenGate configuration in Oracle Enterprise Manager. It also comes with Oracle GoldenGate Director, which allows you to remotely configure and manage Oracle GoldenGate instances. Another product can be used with Oracle GoldenGate is VeriData. This is a data comparison and repair tool. It compares two data sets and lets you know what data is out of sync. This tool works efficiently even with high-volume live environments where you cannot turn the application off to verify the data integrity. Oracle GoldenGate can deliver in up-to-date data to most popular big data solutions, including Apache Hadoop, Apache HBase, Apache Hive, and Apache Flume. It also enables easy integration with additional big data systems such as Oracle NoSQL, Apache Kafka, Apache Storm, Apache Spark, and others. GoldenGate can stream transactional data into big data systems and keep the big data repositories up to date with the production system. In addition to those products, Oracle also offers Oracle Data Integrator and Oracle GoldenGate for the cloud. It can be used for bulk loading your enterprise data to the public cloud. Oracle GoldenGate is SOC 5 compliant, which enables you to replicate the data to and from a cloud database. The service offering by Oracle GoldenGate for data integration and replication to the cloud is called Oracle GoldenGate Cloud Service, or GGCS. Oracle GoldenGate Studio is a what you see is what you get GUI interface, which enables you to quickly build and deploy Oracle GoldenGate replication solutions. It provides you with templates to quickly build configurations aligned to the best practices. I hope I assisted you in achieving your goal of attending this course. If you have any question or comment, please do not hesitate to contact me on any of the communication channels shown in the slide. Till seeing you in a different course, thank you very much.